Hello, this is Paul from Foresight Tech. In this video, we are going to deal with the first order linear differential equation, which is a simple and well-studied type of differential equations. Let's see the material. First, I will going to introduce the integrating factor method, which we can use to solve the first order linear differential equations. Then we will practice two questions together about how to use the method, including an initial value problem. First, let me see this equation, equation 1. And this equation, we call it the standard equation for first order linear differential equation. Okay, it's the standard equation. Why we call it the standard? Because the coefficient of y prime, which is the first order of derivative, is 1. And why we call it the first order, you know, because we only have the first order, the first derivative, okay. The why we call it linear, because see, y prime and the y are linear in the equation, okay. And p is the coefficient of y. Q is just like a constant term. Do you think the last topic we learned the separable equation works for this equation? No, usually not. Okay, and if Q equals 0, and that's good, that's separable of x and y. And usually, if Q does not equal to 0, okay, x and y cannot be separable. Okay, therefore we need to seek another method. So the classic method we call the integrating factor method. Here is the steps. We need to go through 5 steps. Okay, so let me see. The step 1. And we need to find the integrating factor. Okay, here is the order tricks, the most important one. Okay, let me highlight this for you. So all we need is to find the integrating factor by this definition. You will see it's very strange why we need this. And later we were going to see this is the most important. Okay, the ix defined by this composite function, and e raised to a power. The power is antiderivative or integral of px. P is the coefficient of y, and you know when we do integration, we have a plus c on the top, right? And all the c works for this method, so we choose the simplest, which is c equals 0. Therefore, you can just ignore c. Okay. And the second step is this. Multiply both sides of equation 1 by ix. Can you see? If we have I multiply to the first term, we get this. Multiply I to the second term, we switch the order, we get this. Multiply this to the right, of course, we get it the right side. This is the second equation, right? Now, we move to the left side. Okay, the left side, exactly we can follow this product rule. Okay, and imagine if this is true, if y times I take a derivative equal to left side, therefore equation 2 goes to equation 3. See, is equation 3 is much more simple. Okay, why this is true? Of course, you need to go back to product rule. The product rule is this: two terms. The first term is take a derivative to the first y, right? The second should be y times I take a derivative. Okay, I will going to verify I take a derivative just equal to I times p. Okay, therefore, so this left side we can rewrite into this term. Let me show you here. We're going to verify I take a derivative equals what? Where is I? I is this composite function we defined, right? Composite function, take a derivative, we have to use a chain rule. Okay, the derivative of the outer times the derivative of the inner. The outer function is e raised to the user power. Okay, take a derivative is itself, which is e raised to this itself. This is the derivative of the outer. Let me write the derivative of the inner. The inner is this. The inner function is the power, right? This is the inner function. And take a derivative. This chain rule. Of course, I simplify. And the first term by the definition is ix. Okay. See, almost. What is the second term? This is antiderivative. Take a derivative, of course, go back to px. That's the definition, right? Times px. Can you see? That's true. So I take a derivative is I times px. Therefore, the third step is true, right? Okay. So now we have equation 3. And how to do? Integrate both sides. Therefore, the left goes to this. The right goes to integration. If we can evaluate the integration, of course, now equation 4 will go to much simple, right? And how to get y? The last step is just solve for y, which means divided both sides by ix. We get the final equation. Okay, and this is the method. And finally, we have a formula. And now we will move to practice 2 questions together. I will not use the last formula. I will go through all the steps, going to practice the method. Let me see. 5 steps, right? So the first, is this a standard equation? Yes, okay, because the coefficient is 1, and the p is 2x, was q, which is 1, right? Okay, so I will go to the first step. What's the first step? Integrate to find the integrating factor. Okay, so I will write it here. We're going to find the integrating factor. Okay, integrating factor, which is ix, right? What is the ix? I will going to do calculation. So is here ix equal this. To remember the definition is e raised to px. Take a do integration. P is 2x dx, right? Okay, so now this is easy to do calculation. This is the power, so e raised to x squared plus c. We take a c equals 0. Okay, equal to c. The first, easy to get the integrating factor, which is the most important for us in the method, right? Now the second step, what to do? And the times the integrating factor to both sides of the equation, or we simply say I will going to multiply and both sides of the equation by the integrating factor ix. Okay, see what I get. We will get this. We will get y prime times ix. Okay, what is I? I will directly put the I here, which is e raised to the x squared power. Okay, and then plus. And the 2xy up, switch the order a little bit up the y to the beginning. So we have y times 2x e raised to the x power. This is the second term. What the third? What's the right side? Times the ix, which is the ix. See, the second step. Now, what the third step? Okay, rewrite. Okay, is the left side using the product rule. Let's see. Let me show here. We call the product rule. Okay, so we will use the product rule to rewrite the left, which is y times ix. Let me see. Is y times ix is e x squared. And this big term take a derivative. You can go to verify. Okay, so this take a derivative exactly is the left side, and then equals. See, this is the third step. Now much simple, right? Okay, what is the fourth step? Which is integrate both sides. Okay, let me going to integrate both sides. So integrate both sides. We will get another simple equation. Okay, integrate the left. What do we get? We get a y, right? Times e x squared. Integrate the right, we get this e x squared to integration. I cannot get an answer for the right sides because we learned this before. Okay, so this is belongs to non-elementary type of integral. Do you remember? So like a Gaussian integral. So we cannot get a explicit formula. Therefore, we stop it here. Now the last is solve for y. Let me write it. And we have to solve for y. Easy to solve, right? Divided by e raised to x squared, both sides. Therefore, we have this. So we finally get y is e raised to the negative x squared and integral e x squared dx. This is the final we already get. Okay, so for the first question, and the 5 steps, keep in mind integrating, multiply, product the rule, integrating both sides, and that's all for y. They're not so difficult, right? And this is the amazing method. Now we move to one more. Okay, we call the initial value problem. Okay, and initial value, because we have an initial condition. Okay, we use this condition to the general solution, so we will get a specific solution. Okay, so the first, I'm going to find a general solution. Partition. Okay, and can you see here, the coefficient of the derivative is not 1. Therefore, so this is not a standard equation. We have to do what? Change this into a standard equation. And excuse me. This is the first step. Okay, make sure don't miss this. So, and then we do this. We're going to get a standard equation. Okay, what is the standard equation? Our put here is divided by x both sides. Therefore, we have what? We have y prime plus 2 over x times y equals ln x over x squared. Can you see? This time, this is the standard equation. Okay, the coefficient of derivative is 1. And what is p? 2 over x. What is q? This term. Okay, exactly we follow the formula we just introduced. Step by step, now we move to the first step. Find the integrating factor. Okay, so we're going to write, which is this, which is ix equals what? I will use the definition is e integral p. P is 2x, right? And then dx. Okay, so do calculation is easy because this is reciprocal. Reciprocal, we have this. We have natural logarithm as the end derivative, but don't miss the absolute value. Okay, so I put this looks complicated, but we can simplify. Don't worry. And the 2, and put it back to the power of x, which is the power rule. And then e, and e is the inverse rule. So what do we get? We will exactly get x squared. Okay, so can you see this is much easier? Okay, the first step done. Then we move to the second step. Multiply both sides by the integrating factor. So what do we get? We will get this. In the multiply this standard equation, keep in mind, don't go back to the original equation. Okay, so multiply that to the left, which is we have this, the first y prime times the ix, and the second term, this time is x squared. So what do we have? We have 2x left, right? I will switch the order. So I get y times 2x. See, to the left. The right times x squared. So we cancel x squared. We get ln x. So we have ln x. See, and then now the third step, what do you do? You remember, okay? So we use product rule to the left side. So we wrote into this simple way, which is this y times ix is x squared, and take a derivative equals ln x. You can go and verify this is exactly true if we're using the product rule. Now the fourth step, integrate both sides. So what do we get? We will get this. So integrate the left, we get a y times x squared, and integrate the right, which is integral ln x dx. Do you know how to do this? We know how to evaluate. Okay, we learned that before, and this is the basic type of integration by parts, right? Okay, let me write a little bit. We can use integration by parts. Okay, integration by parts. What the parts? Of course, u is ln x. So let me write, and u is ln x. Was dv? dv is dx, which means uv equals x, right? If someone you follow, v this time is x. Okay, now we plug into the integration by parts formula. U times v, which is x times ln x, minus, okay, and you use v du and do integral, and I definitely will get it. It's just minus x. Don't forget plus c. And here, so we finished the first step. Do you remember the last step? Solve for y, right? Easy. Divided by x squared both sides. Good. I will going to solve for y, and we will get a general solution. See, we solve for y, which is y equals divided by x squared. Let me use these first two terms divided by x squared, so we can cancel x, right? Good. So what do we get? We will get this fraction. We will get this fraction, which is ln x minus 1 over x, and then plus the second over is c, constant number, over x squared. Can you see? And this we call the what? You know, now we get a general solution. Okay, so we call the general solutions. C is a constant number. We have an infinite number, right? Infinite solution. However, if we look back, we have this initial condition. We use this information to solve for C, the last. Okay, we do this. We are going to solve for C, right? You know, it's just solve for C by the initial condition, which is y at 1 equals -1. So this is from the question. Okay, we copy that to here. See, that the last. Okay, easy to do. And this is equation. With all equation, we get C. Let me write the little steps. Okay, so y at 1 equals what? Y at 1 just equals plug 1 into the left. Okay, into the equation. ln 1 is 0. Therefore, the first is -1. So -1. And the second is plus c, right? Equals what? -1. See, that's easy to get. What is c? C is 0. Okay. And then the last one is just plug c and 2. And the general solution, we find the specific solution. Okay. Which is this. So we have y equals how many? Okay, is that fraction. So let me just put this. Okay, is ln x minus 1 over x plus c is 0, so this is 0, and that's already the final answer for this question. That's all. Thank you. If you have a question about this topic, please leave your comment. If you like this video, please give me a thumbs up, and you are very welcome to subscribe to my channel for more videos. Thank you for your support. In the next video, let's see, we are going to move to chapter 10. We are deal with the calculus of parametric equations and polar coordinates. Hope to see you there. Thank you. Have a nice day. Bye.